Hi everyone, in last video we have finished a DC motor that is self-excited, and in this video we are going to learn about transformer, what's the principle of this, and what are the types of transformer, what are the windings involved in it. And in the next video we'll be going to learn about working of transformer when it is at load and when it is at no load. Now coming to this topic, see, firstly, transformer is nothing but, see here, we are choosing only a single phase transformer. Okay, just remember this point. Here we just talk about a single phase transformer. So this transformer will transfers electrical energy from one level of voltage to another level of voltage. I will explain this in detail, just wait for a minute. It transfers electrical energy. The transfer of electrical energy from one level of voltage to other level of voltage means, in the sense, I'll explain it here. Generally, we have like generator. So in generator, that voltage was measured in kilovolt. Okay, so since this was in kilovolt, that means it was in huge amount, right? So we say to be that the voltage is stepped up. Okay, it is stepped up suitably. Generally, you may get doubt, how can we get this power to our homes. Okay, so there will be few transmission lines. Through the transmission lines, it will come from the transformer. Okay, from the transformer, actually at the transformer, it was stepped up to a suitably very high voltage. It is having high voltage, and from that it will reach us to substation. So in substation, there will be not much as that in generators. So it will get reduced, that voltage will get reduced. It means from more units, suppose it is having 10 units, while coming to substation it reduces to 8 units. It means your that voltage is getting dropped, right? So we say to be consider it to be the voltage is being stepped down, and from then we'll get power to our homes. Like, see, simply I'll say, um, there will be transmission lines for firstly it will start from a point, right? Like from a generator where it generates this voltage. So from there it will start, and there the voltage is suitably very high. That means it is stepped up at the starting point, but when it reaches to substation, there will be some voltage drop, and further, that means it is getting stepped down. And again, when it reaches to our household purposes, like we'll get electricity for any household or in shops, like that. So for that it should further again reduce. It means again it is stepping down. So from this we can understand that what is transmitting here, the electrical energy is transmitting from one level to another level, that is either from higher level to lower level, like that. In that case, like in that sense, we define it as the transfer of electrical energy from one level of voltage to another level of voltage, and it is considered to be a static device, and the generator voltage is generally measured in kilovolts, so it is stepped up suitably. Hope you are getting these points now clearly. And through the transmission line, it will come from the transformer. So firstly, at transformer there will be very high voltage, and when it reaches to the substation, the voltage gets dropped. That means the voltage is stepped down at that point, and from there we'll get power. So to our household circuits, sorry, to our household purposes. And at that moment again it will get stepped down. Okay, in generator it will get stepped up. It means stepping up and stepping down of voltage, and the transferring of electrical energy from generation to substation and our homes, like from generator to substation and then for our homes. This is nothing but your transformer. And what's the working principle of transformer? Please don't get worried about this handwriting, it is not at all good. So here we have this transformer works on the principle of Faraday's law of EMF. What is meant by Faraday's law of EMF? Already we all are aware with this term. in our 12th standard. Faraday's law states that whenever there is a change in magnetic field, remember, whenever there is a change in magnetic field within a coil of wire, an EMF get induced, like EMF or voltage gets induced in that coil. Okay, the magnitude of this induced voltage will be directly proportional to d phi by dt. That means the rate of change of magnetic flux, which is nothing but your Faraday's law of EMI, that is changing in a magnetic field. See, simply remember, whenever there is a change in magnetic field within a current carrying coil of wire, at that moment EMF gets induced. Okay, this is nothing but your Faraday's law of EMI, and this opposes the cause due to which it is produced. Okay, see, in transformer, when voltage is high and the current is less, see, current is less means your conductor size will also be less, right? It means, in simple terms to say, so in order to transfer of this electrical energy, there will be some like wire type now, like there will be some conductors. So if we have that conductors of very large size, then it would cost us more, right? But if the conductor size is small, then it will be like cost efficient also. So when the voltage is high and current is less in a transformer, that means conductor size will also decrease, so less cross section will be needed. Less cross section will be preferable, since it will be cost efficient, right? If it will have the more cross section, then it was not efficient, because it will takes much cost. Nobody wants to spend anything with more money, right? And steps up the voltage means nothing but your current gets reduced, and steps down the voltage means nothing but your current will get increased at that moment. Okay, and coming to this types of windings, so this transformer will have two types of windings. Those were defined as primary windings and then secondary windings. Remember, this point is very important. These primary winding and secondary winding will not be in direct contact at any cost. They are not electrically connected, just they are insulated for each other, so there will be no connection between them. Instead, we like separate them by using core. They are insulated from each other. So here, without core nothing is possible. Without core there will be no transfer of electrical energy also. So this is about your windings. And now coming to the like, this was like simply a coil made of copper, like that. Okay, now coming to types of transformer, here you will be having step down transformer and step up transformer. See, whenever if your primary winding, like it is having more number of turns, and the secondary winding which is having less number of turns, it is said to be step down. So in order to avoid confusion, I'll give you a simple tip. See, if you can see here, it is at higher position but it is at lower position, it means you are moving bottom, like you are going down, so it will be step down transformer. Okay, here it will be more number of turns. When the primary winding has more number of turns and the secondary winding has less number of turns, then it is said to be a step down transformer. Okay, and the step up transformer is quietly opposite. Whenever your primary winding has less number of turns and the secondary winding has more number of turns, in that case we say like we define it to be a step up transformer. This is all about your step up transformer, step down transformer, primary winding, secondary winding, and what is meant by transformer, how can we define it from one level to another level. So all we have discussed till now, and in next video we will be going to learn about working of a transformer at load and at no load. And if you find this video to be helpful, please comment me that it really helps us, because that will boost my energy in order to make more videos further. And thank you for watching, and subscribe my channel for more videos.